All right, Unit 2, Lesson 2. This is Chapter 8, Section 8.2 in your book. Students will be able to simplify radicals with an index greater than 2. So remember, when there's no number there, the index is considered to be a 2. When there's a different number there, they will write it in there. Okay? So the index is still in the same place. These are all the same things. It says, while square roots are the most common type of radical, we can take higher root numbers as well. Cubed roots. Cubes, that's a cube. 3 is cube. Fourth roots, fifth roots, etc. We'll be continuing working exclusively with positive radicands in this unit. Talking about other ones later on in the end of the lessons here. So the square root of 16 is 4. Turns out that 16 is not only a perfect square, it's also a perfect fourth. Okay, so as you're working the problem, you need to pay attention to the index. The square root of 16 is 4, but the fourth root of 16 is 2. Fourth root, right? Square root. So 2 2's, well, here. Sorry, let me do this. Getting carried away, hang on. All right, so 4 times 4 is 16, okay? But the fourth root of 16 times 2 times 2, you need something 4 times itself, okay? So the cubed root of 8 is 2, right? The fifth root of 32, if you have 4 of these and you put another one on there, you're going to get 32, okay? 64 is a perfect square of 8, 8 times 8. But if you take 4 times 4 times 4, you also get 64. So it's a cubed root as well. So that's why it's important to kind of add these to your flashcards here. Those are the ones you want to keep handy. We're going to be looking for those as factors. Okay? The perfect cubes, the perfect fourths and fifths. Keep them handy so you can recognize them. So 8 is a perfect cube of 2. Okay? 2 times 2 times 2. Put an equal sign there. Okay. Cubed root of 64 is 4. Okay. Fourth root of 16 is 2. Well, wasn't 81 a perfect square? It's a perfect square, but it's also a perfect fourth. This is, think of this. This 1 times 1 times 1 times 1 is 1. Okay? So these 1, 2, 3. So 81. Check in your calculator if you want. 3 times 3 times 3 times 3. That's 9, right? 9 times 9 is 81. So the fourth root of 81 is a 3. And then 1, no matter how many times you multiply it together, it's a perfect fifth, it's a perfect fourth, it's a perfect cube, it's a perfect square. Okay? All right, so cubed root of 125. Cubed root of 125, it's a perfect cube. So 2 times 5 is 10. Okay? Fifth root of 32. 7 times the fifth root of 32. The fifth root of 32 is a 2. All right? Fourth root of 256. 256 is a perfect fourth of 4. Negative 3 times 4 is negative 12. Cubed root of 27. It's a perfect cube of 3. And a 1. Okay?